My name is Jonathan Petit-Frere. I'm a software engineer at Button here in New York City. I work on the mobile team, specifically on the Android team. And if you have any questions kind of about Button and kind of like what we do, feel free to ask me questions after. With a show of hands, how many people here is familiar with Android development? Nice. And how many people here is familiar with Android things? Okay. Nice. All right. Well, this is my talk. It's an intro to Android things. It's a pretty intro level talk. You'll see what I mean soon. All right. So this is kind of going to be our agenda for today. We're kind of going to go through kind of like an overview, kind of like what Android thing is and kind of like why you should actually use it. Then we're kind of going to go through like kind of like the history of it and kind of like how it actually came to be, because 1.0 was actually released earlier this year, and kind of just like how it actually compares to the regular Android framework, and kind of just like just an overall kind of like look on how like the hardware actually works and how you actually connect different peripherals, different like things like that, and of course kind of like how you can actually get started for like hobbyists just like myself. Can just literally start prototyping, just like making things kind of just whenever you want to. And also, I'll have some time at the end. So if you have any questions, feel free to ask any questions, and please walk up and speak into the mic if you have any questions. All right. So first thing is kind of like, what is Android Things? Android Things is an Internet of Things operating system that lets you build connected devices. It basically allows you to actually create these connected devices with kind of like limited knowledge of embedded system design. So kind of like the biggest takeaway of kind of just like why Android Things is such a powerful thing. There's not really that much that you actually have to learn, kind of like on top of like your regular Android development knowledge. You still use the actual same tools that you normally would use, like Android Studio, same libraries, like if you're using like retrofit, play services, just essentially anything that you can do, just regular developing regular Android applications. You can actually use that to actually create a connected devices depending on what your use case is. In general, it reduces the upfront cost because I don't know if anyone actually tried creating like a connected device before, but there's a pretty big there's a pretty big process that you kind of have to like go through in order to actually even get like choosing the operating system. Then sometimes you have to learn different languages just to kind of like create different drivers. But since Android things, the whole point of it's kind of like use like your prior knowledge of just Android development with it. It kind of makes the transition of it kind of like easier, even though it's kind of like a different realm in embedded system design. And the way Google actually created Android things, developers actually manages the apps and different drivers that you create for the different peripherals that you're using, such as like if you want to use like GPS, accelerometers, like thermostats, and just like all of these kind of like different things like motion sensors, which I'll kind of show you a demo of kind of like later. And Google kind of manages everything else when it comes to like security and just the overall hardware and actually like getting it actually up and actually running. So this may actually look a bit familiar to some folks because it's essentially Android. The Android framework is kind of just like split up between these different levels, but this is actually Android Things, and kind of Android Things actually extends the core Android framework, and it actually includes an additional API. You can see there, it's called the Thing Support Library, and that library itself kind of like allows you to kind of have better like access to the actual peripherals that you're actually creating kind of like the drivers for, whether it's like a motion sensor or just a regular camera, just all depend on like the use case of what you're actually trying to build. System apps in general are actually not present in Android Things. It's mainly to like optimize a startup, and because Android Things runs on low powered devices. So in order to kind of like optimize it, there aren't actually aren't system apps, and kind of just there's some other stuff with actual storage requirements. And so in general, how it also compares to just regular Android is that Android things actually just runs one app at a time, as opposed to like your phone or your tablet. It'll be running multiple apps at once. But Android thing is kind of just like it's literally just single responsibility. It'll just run at one app at one time. Okay, so to kind of like go through like the history of kind of like where Android things kind of just like originated from about 3 years ago. It was actually announced at Google I/O in 2015 under the name Project Brillo. And there wasn't really much about it other than like, hey, we're getting into the IoT space, and that's kind of about it. And then I want to say about a year and a half later, when we actually got the first developer preview, and it was the first public version of what Android things basically is today. It had a lot of issues. For the first version, but it was definitely something kind of like really good to kind of like look forward to if you're kind of like interested in making these connected devices. And then shortly after, I'm just gonna kind of highlight a couple key things, kind of like each preview actually kind of brought together. But shortly after, in Developer Preview 2, they added USB audio support, which is kind of like a big thing, because there's a lot of people like the Google Home just kind of like recently came out around that time, and some people were trying to like kind of like mimic it, kind of like do it like their own like do it yourself approach, but you couldn't really do it without actually like USB audio support. And then shortly after, they actually because in the Developer Preview 1, the actual like the Bluetooth APIs that you normally use and like when you're just regularly just developing for Android was actually disabled, but they actually enabled it in Developer Preview 3. And also in Developer Preview 4, that's when they actually started audio APIs. This is when they're actually like working with like the raw peripherals that you're actually connecting directly to these low power devices. It allows you these APIs basically allows you to like to basically send like the audio to these actual peripherals. And in 4.1, they actually introduced kind of like a new variant of Play services. I'm not sure if anyone actually tried importing all of Play services dependencies before, but it's a pretty big it's a pretty big library in general, which is why they kind of like broke it down into you kind of include like what you actually want. But they kind of introduced like Play services for IoT, which is kind of like a stripped down version of the Play services, and it's just optimized for Android things. And in Developer Preview 5, they introduced the Device Manager API, and that was a really big thing because without having like system level permissions, there was no way you can actually restart the device. You couldn't reset the device, and like this API introduced that new thing. And in 5.1, there was a lot of various bug fixes that kind of fixed a lot of the issues that was actually happening with the Device Manager API. And in Developer Preview 6, they actually introduced Update Manager, and this kind of allows you to actually, so because displays are kind of like optional in Android things, if you did have a display and depending on your use case, if you wanted to kind of like have like a check for updates button, there was kind of like no way you can actually do it without having to roll your entire own solution to kind of like push out the OTA updates. But the Update Manager allows you to do that, along with the Android Things console, which I won't really be getting into today, but that kind of allows you to kind of like push all of these new images and like the new apps to your connected devices that you already released out in the world. And then in Developer Preview 7, they added MIDI support. You can either build your own virtual MIDI device, or if you kind of want to just interface with an actual external one. At Google I/O, or actually earlier this year, there was actually a lot of demos that actually included that MIDI API support. And then shortly after, we had Developer Preview 8, which is kind of like the first public release candidate. And one day before Google I/O this year, they actually released 1.0 of Android things, and I think we're on 1.03 right now. So I'm going to actually start talking about kind of like how Android actually compares to Android things. They're pretty much the same, but there are some small like low level differences between them. Just in general, like the kind of like the key things I kind of wanted to highlight was kind of like the API availability, content providers, play services, and permissions. Those all work completely different from kind of like how you'll normally actually develop with Android. But in general, because GUIs are actually optional with Android things, it doesn't. There's a lot of APIs that's included inside the Android framework that will not work on Android things. Specifically, the ones I'll probably mention is like the notification manager and like the NFC manager. And there's actually a full list of like unsupported APIs that the Android framework actually includes, but the Android things doesn't actually support on actual developer website, which I'll actually have a link to later on. But in terms of like the content providers, so there's like because Android things doesn't have like just like the regular system apps that you'll normally have, like your alarm manager or just like your clock and like different things like that. Using things like common intents or something that you should avoid in general doing, just because there's actually like no application it can actually open to actually kind of like run these different actions. So if you want to like call an action to like open up the phone dialer, to like call someone, like, you should probably avoid doing that because it's most likely not going to work. And if you kind of like not sure about like what can actually work and what can work, there's actually the has system feature method that you can actually use to kind of like check that programmatically, so you're not crashing your app. So Android things supports a subset of play services, and because Android things actually does not get shipped with the Play Store, it doesn't have actual Play Store in it. There's actually which is actually responsible for updating Play services on all your mobile devices. The actual image that you actually flash on these connected devices actually includes like a static version of Play services. And if you wanted to update it, you'll just basically push another update, another OTA update to these devices. So in general, they'll target the latest release. I think 1.0 right now targets 12.5, but I think the latest version might be about 16 for the Play services. Might be about 16. So when you're creating kind of like these devices, you have to take that into account. And so if there's like a new API that was like or a new method that was introduced in Play services in like version 15, you probably can't use it until there's an actual image of the actual Android things that's actually able to actually use that version. And granting app permissions is completely different. It's essentially like the Wild Wild West. So when you're like developing and like kind of like prototyping in general, whenever you actually install the actual app, actually all the permissions actually granted all at once, and that does not happen in production at all. But when you're actually like prototyping and kind of like testing, everything is kind of granted. You can also use ADB to kind of grant and revoke permission as needed for your different use case. But that's just kind of just like how it works from a development standpoint. In production, when you use like the Android things console, you can actually specify which permissions you actually want to enable in that specific production image before you actually flash it on your actual connected device. Yeah, for more information, like the full list of kind of like unsupported API, I would definitely take a look at the Android things like developer documentation website, because there's a decent amount. I didn't want to list all of them there, but there's still a lot that you can do with the available APIs. All right, so in terms of like hardware that's actually supported, right now there's only about 2 development platforms that you can actually use. One being the Raspberry Pi 3 Model B. I do not think the Model B Plus works. I've never actually tried it before, but I wouldn't recommend it. But as you can see, there's actually different development only platforms, and then there's production platforms. I would probably recommend, if you're just starting out and kind of just like prototyping, just like testing stuff, stick to kind of like the development platforms, because of just how powerful and how Android things is made. you can essentially use the same code that you use on the development platform, and you can just port it over to the production platform with literally zero work at all. I would say there's a little bit of work because you just have to configure the pins, but that's about it. And the reason why you can only use the development platform kind of just obviously for development, because they just do not meet all the security requirements that Google kind of needs. So to kind of like push out like OTA updates and stuff like that to like ensure that you kind of like have like these secure devices in the wild. And all of these production platforms that you see here, they're all fully supported for, I think, a minimum of about 3 years. So you'll get like stability and security fixes for at least a minimum of 3 years. So if you're thinking about just like releasing a product powered by Android things, you wouldn't have to really worry about kind of like is my device going to get security updates for about 3 years. I think after that you can probably do like some kind of like extended support with them, but as of like right now, you can kind of just they're kind of like the free updates is for about 3 years. Okay, and kind of earlier today, I kind of spoke about the Android Things support library and Android Things kind of like stack. So in general, when you're kind of like working with peripherals, when you're referring to working with Android things, there's kind of like a couple ones that I'm just gonna kind of like list. The first one being GPIO, which stands for General Purpose Input Output. It's a pretty simple pin. It's only kind of like used for like simple sensors that kind of like work as a switch. And they kind of like their state kind of is like just like binary. It's high or low. And I should be talking about GPIO a little bit later. And then you have PWM, and that's kind of like used for like motors and like certain lights. So the only reason why, because they kind of like require proportional signal to kind of like have like a fine grained control over it. So an example of that would kind of be like if you're using like a motor or something like that, and you kind of want it to go a little bit faster, you can kind of like fine tune it so it's actually like you can get it to go like, let's say 5 miles per hour, you can get it to go 10 miles per hour, and just kind of like being able to actually kind of like control the actual like acceleration, so it's not like just like 0 to 100 and that's it. And next one is integrated circuit or IIC or I2C. It just depends on how you want to refer to it. But those are just like that's kind of like the protocol, like the peripheral API that you'll actually use for like different peripherals that require different kind of like connectors. Some of them support honestly all of them. Some of them support one, or some of them support none. Some of these are pretty like industry standard. So I feel like for most peripherals that you'll just prototype with in general, you should be able to find like these connectors and kind of like these APIs needed in order to actually create the driver from. And for some, I would say for some peripherals, there's some actually already created for you. I believe it's on the Android Things repo. There's like a contributors drivers page on GitHub that actually has just a bunch of drivers that's already created that you can just literally just use and not actually have to look through the documentation of a bunch of peripherals and trying to figure out how to actually write a driver for it. And kind of like an example of kind of like a peripheral that kind of like use the IIC would be like accelerometers, thermometers, and like LCD displays. And for the last one is SPI, which is serial peripheral interface, and that's usually like different peripherals that kind of like require like a really high bandwidth, and that would kind of be like graphical displays. Okay. So kind of like what we'll be doing for like the next couple slides, I'll show you kind of like how to create a really simple driver. And the easiest thing I can really think of is kind of is creating like a motion sensor driver, because it's kind of like the easiest one that I feel like it's pretty simple to actually kind of like wrap your head around, because it's kind of like it's on or it's off. And kind of like these are going to be our like 3 steps to success. First one is in general, you just have to flash the image on the actual hardware. The one I'm going to be actually talking about in examples will be the Raspberry Pi 3 Model B. And Step two would be to connect the actual hardware. I'll show you exactly how you can actually connect the actual motion sensor peripheral to the actual Raspberry Pi, and what it actually means when you're actually in the third step, creating the actual driver. So for the first step, I definitely could list out a bunch of steps on how to actually flash an image, but I would say like the easiest way to honestly flash the Android Things image is honestly to use the Android Things Toolkit app. It's in the Play Store. It's a pretty detailed app on how to actually flash it, and it'll show you how to connect everything when you're actually working with the Raspberry Pi 3. And right now, so this is actual image of the pins on a Raspberry Pi 3. All of them actually are color coded to different things. The only one we're really going to worry about today is specifically like the green ones, which are GPIO pins that I mentioned earlier. Black is ground, and the names that you actually see to the sides of the actual pins are specifically like the specific names of the actual pin, which I'll actually get into later when we're actually creating the driver. So this is kind of like an image of how you would actually connect the actual motion sensor to the actual Raspberry Pi. So the black wire from the motion sensor is actually connecting to the ground pin on the Raspberry Pi, and the yellow wire is actually connected to the GPIO pin called BCM4. And the red wire is that's just for power for the actual sensor, and then just connected to the 5-volt pin right at the top. And now just moving on to our first creating our first driver. So many of you have probably seen this before, but I just thought about just including it mainly because this could change at any point. I'm running Android Studio 3.14. So the steps that I kind of included here might be different. Might be different in different versions of Android Studio. But in general, you'll start a new project, then you'll name your app. In this example, I'm just calling it Intro to Android Things, and I'm actually just choosing a blank activity. And obviously you have to name your activity, but in this example, I'm not going to actually generate a layout UI file because we don't actually have a display that we're actually working with, so we don't actually need to actually have a layout file. So the first things you'll probably have to do, like immediately once you're trying to create your first driver, is go to the manifest and update and just add this permission. Kind of like what I said earlier, kind of about like how all the actual permissions are granted, but you still actually have to include it in the actual manifest if you actually want it to work. And depending on what version of Android Studio that you're using, you might have to update the manifest to, for some reason, the older versions will include something called the IoT launcher category inside the intent filter on your activity. You'll just have to update that to home instead of IoT launcher. And basically what that does, anytime you actually power your device, when it automatically turns on, it will automatically start that app and that activity. Okay, and the next step, the next slide is kind of like what the actual driver is. So in general, I kind of spoke about earlier how we connected the motion sensor to the BCM4 GPIO pin. So you can call the peripheral manager, get the instance of it, and then you can call open GPIO to actually open up the pin. Then you kind of just have to like set it up, whether if it's an input or an output. In this case, since it's a motion sensor, it's actually an input, and you have to set the active type. So for this specific motion sensor that I use in this example, when the voltage is high, that's when it's actually considered active, and also that's when it actually is considered that it actually detected motion. And also you have to set the trigger type. So you can set the trigger type so when it goes from low to high, or when it goes from high to low. In this case, I'm actually looking at both. And of course, you have to register your GPIO callback. So whenever the actual like voltage changes on that specific BCM4 pin from low to high or high to low, it'll run this code right here. And all I'm basically doing is the value is returns returns a Boolean. I'm just checking if it's true. That means that it's actually in its active state. And in this case, because we're working with a motion sensor, that means that motion was actually detected. And when it actually goes back to the low state, that means that it didn't find any motion at all after there's like a polling rate. And I returned true just because I wanted to keep on actually listening to this. In certain use cases, in certain peripherals, you don't, after a certain point, you kind of want to like return false, or yeah, certain use cases. I can't really think of any right now, but definitely like in this case, we want to keep kind of like getting these updates, and kind of just like whether or not if the motion sensor actually detects motion or not. And of course, whenever you're actually closing it, make sure you unregister your callback, and of course close the GPIO pin. So this is kind of just like what we kind of like went over today, kind of about like what is Android things, and kind of just like the history of it, and kind of like how it actually came to be, and how it actually compares to Android things and just regular Android framework. And also, obviously, the supportive platforms, and how to actually get started. And for more information, I would definitely recommend going to this website. It's a really great website. It's pretty up to date with their documentation. And also, there's pretty good code labs that you can also use in starter kits that they use actually with the app that I mentioned earlier that you can use, kind of like step by step on like how to actually connect it and get it actually running. Any questions? Make sure you say the question on the mic. Yeah. So.
You were talking about Google Play services update over the air.
Yeah.
Like, does it really update like automatically, or do you have to?
So with the Android Things console, I can actually probably show you a picture of it. Actually, give me a second. So the Android Things console, it's pretty nice. It kind of looks similar to the Play Store console, but it's specifically for like these connected devices. I just have to find it real quick. So part of like the process of like when you're actually using the actual application, when you're using the application to actually install the image on it, it'll kind of ask you whether this is development platform or not. You kind of like specify it, because some like OEMs, some of them would try to stay at a certain version, because they're probably like the same issues that we'll probably have right now with kind of just like I don't know, like if P had like a real like targeting P right now would have like really bad issues with your app right now. It's kind of like a similar situation like this. So you can kind of like specify like what version of Android things you want on 1.0, 1.01, 1.02. You can always specify that. But with those, you'll create a brand new image, and then you can literally bundle all the apps that you actually want inside of that Android things image, and then you can just push it, and it'll automatically do it just like the Play Store basically does with regular apps.
Okay, but do you have to rebuild your app and
you don't have to you don't have to rebuild your app unless you have to like fix like any issues for that specific version, because they kind of like have this specific area where you can kind of like, it's like artifacts that you could, so all the APKs that you kind of like want to include inside your Android things image, like you can include it there. You don't have to keep re-uploading it every single time, but you do have to make a different image if you want to actually target like a different version of the Play services.
Oh, okay.
Yeah. Cool.
So, how easy would it be to connect an Android things device to send like, I don't know if you can hear me, send like messages or anything like that to like a phone or something like that?
I mean, depends on how you want to send the message. Just like, because you can use honestly the same libraries and tools that you use with Android. So if you can do it on like a regular just like Android device, I mean, you can honestly do it on Android things. I would probably, depending on your use case, like I've used like the Play Services Nearby API, and it works pretty well. when you're just trying to do like that short distance communication where you don't have Wi-Fi and when you don't have like and you don't want to kind of like set up Bluetooth and stuff like that. Like the Nearby API is a pretty good API when it comes to just like that kind of like you're in the same vicinity as the actual device and you're not trying to do it over the internet. Okay. If you're gonna do it over the internet, I'll probably recommend like Firebase for like a backend and just update the values on there. Okay. Yeah, no problem. Any other questions? Okay. All right. Thank you.